So we're going to continue our discussion with section 7.2, which deals with estimating a population mean. So example 6, a simple random sample of 15 birth weights of boys in the U.S. is taken with the following results reported in grams. So here are 15 different birth weights from randomly selected boys, okay? So first thing I want to discuss, is sigma given or not? Well, do they say anything about a standard deviation at all in this problem? They don't say sigma is known to be this, or we found the population standard deviation is this. So sigma is not known. So if sigma is not given, you have to use a t interval. Okay? So find the best point estimate for the population mean. The best point estimate when we're dealing with means is x-bar. So you already know how to find the average of a data set, right? That goes back to chapter 3. You can enter your data into a list, press stat, press enter to edit list, and for time's sake, I already have all my data values entered. There's 15 of them. Press the stat button to go over one, highlight calculate at the top, very first option, one VARS stats, right? Press enter, and I enter my data into list 1, leave frequency list blank. And so the best point estimate is the very first thing, x-bar, that's 3,438.533 repeating, right? And I'm going to go ahead and jot this down, because notice they don't give us a standard deviation at all. So that means in this problem, we're actually going to have to calculate it, and we actually have it right here. So I'm going to go ahead and jot this down, because this is a sample. So our standard deviation is not this. That's from a population. It's the 513.5683,103. Okay, so the best point estimate is this here, right? And we're dealing with grams. Okay, so next part, find the margin of error used to construct the confidence interval for the true mean birth weight for all boys. So since sigma is not known, there's two formulas for margin of error. We're going to have to use the one that involves the t interval, or the t critical values, and the sample standard deviation. Right? So we need to calculate this and this. Well, we already have the sample standard deviation. It's right here. So I'm going to go ahead and calculate that critical t value. We want 95% in the middle, right? That comes from our confidence level. Well, if we have 95% in the middle, then there's 5% left over, divided into the two tail ends of the graph. It's 2.5% here as a decimal, 0.025 and 0.025. And so to calculate that inverse t, you have to have the area to the left. Well, the area to the left of this here, this critical value, is you add the two areas to the left. So 0.025 and 0.95. That's 0.975. And degrees of freedom, which is 15 minus 1, so 14. Right, so you go into your calculator, press, I'm going to clear it out, press second, VARS, to open up the distribution menu, and go down to the fourth option, inverse t. And I already actually have it calculated in there, or populated in there, I guess I should say. And so our t value is 2.144478661 ... So I'm not going to round these values until the end. And so our t value, or at least I'm going to go out far enough to where I don't have rounding issues. So that's our t value, 2.144786. Our sample standard deviation, we got that from the data set. That's 513.5683,105 divided by the square root of n. We had 15, right? So you go in your calculator and type all that in. And so your mean is, your margin of error is 284.4045 and so on, right? So they're going to ask you to round probably to 1 decimal place, maybe 2. Depends on the problem. So next part, create a 95% confidence level to estimate the true mean birth weight of all boys is what that should say, not girls. And so you need X bar plus or minus your margin of error, right? X bar, we found part A was 3,438.53 plus or minus. Your margin of error was 284. That was from part B, 0.40. And so to get your lower limit and your upper limit, right, you actually just add and subtract those numbers. And that's going to give you your lower limit and your upper limit. So our upper limit is 3,722.93. And your lower limit is 3,154.13. Interpret the confidence interval. Well, we are 95% confident the true mean birth weight for all boys in the U.S. is between 3,154.13 and 3,722.93 grams. Okay, so now we're going to do it in the calculator. So to do this in the calculator, you don't have to do it by hand, right? We are using a T interval here, so you press the stop button. You right arrow over to test at the top, and you scroll down. You have to decide between Z interval and T interval. In this problem, sigma is not known. They don't tell you the population standard deviation, so we're using a T interval. Press enter. And before on the previous problem, we highlighted stats because we were actually given X bar and S, right? In this case, we were given a data set, so it's easiest to actually go over and highlight data set or data and use the data set that you entered previously, right? List 1. Frequency list, you leave that at 1 because you're using one list. A 95% confidence level, so 0.95, and calculate. So you end up with 3,154.1 and 3,722.9. Right, rounding to 1 decimal place, those are the exact same numbers. Okay. And so to sum it all up, if sigma is known, you construct the interval by creating a Z interval, which consists of critical Z values, right? So it's X bar plus or minus your margin of error, where you calculate your margin of error by using this formula, your critical Z values, times sigma over the square root of n. This is to do it by hand. In the calculator, you press stat, then highlight test, and scroll down to option 7, which is Z interval. If sigma is not known, you construct the interval by creating a T interval, which consists of critical values of T. When you're calculating your margin of error, you use this formula, which consists of critical T values and your sample standard deviation S, which will be either given or you'll have to calculate it. In your calculator, you press stat, highlight test at the top, and scroll down to option 8, which is T interval. You can calculate the intervals either by hand or using the TI graphing calculator. That is your choice. Okay. Okay, so the next part of this section is determining a required sample size. And so what we're looking for here is how large of a sample do we need to collect, right? How many people do we need to survey? What sample size is necessary to have a certain confidence level, right? So you must use the formula below and you must round up to the next whole number. Okay, this is the formula. N equals your critical value of Z times sigma divided by the margin of error, and it's all squared. So we want to estimate the mean IQ score for the population of statistics students. How many students must be selected for IQ tests if we want 95% confidence that the sample mean is within 3 IQ points of the population mean? Assume the population standard deviation is known to be 15. So, how many students must be selected? So we're looking for n, right? We're trying to find what n is, and we're dealing with a mean. So we're going to use this formula. Your critical value of z times sigma over your margin of error. Well, the critical value of z corresponds to the confidence level. Well, we want to be 95% confident. Well, remember that chart where you had your confidence levels? The z-score that corresponded to a 95% confidence level was 1.96, right? Your sigma, the population standard deviation, is known to be 15, so that's sigma. And you want your sample mean to be within 3 IQ points of the population mean. That is your margin of error. And you have to square all of this. So you go into your calculator and type this in. So parentheses 1.96 times 15 divided by 3, all squared, and you end up with 96.04. So your sample size that is necessary is 97. Okay, and the last part of this section is when a confidence interval is given. Okay, if they tell you the confidence interval, they give you the lower limit and the upper limit. To find x bar, you actually add them together, the upper limit and the lower limit, and divide by 2. To find the margin of error, you actually take the difference between the lower limit and the upper limit and divide by 2. So, example 8. Below you are given the confidence interval estimate to estimate the mean miles per gallon for all Toyota Tundra trucks. Use the confidence interval to estimate the mean, the sample mean, and the margin of error used to construct the interval. So we're actually given the lower limit and the upper limit here, right? So to find the x bar, it's actually exactly in the middle. So you add the upper limit and the lower limit and take that sum and divide it by 2. So 17.2. And to find the margin of error, you take the difference between the upper limit and the lower limit and divide by 2. So you end up with 1.1, right? So your sample mean is 17.2 miles per gallon. And your margin of error used to construct this interval was 1.1 miles per gallon. Okay, and that is it for 7.2.